Europe, Middle East and Africa. And I'm going to talk to you a little bit today about mobile app development using the cloud, using the AWS cloud, of course. Who's using AWS today as a backend for apps? Okay, a minority of people. So let's just talk a little bit about what AWS is, and then we'll get into some mobile use cases. So Amazon Web Services, it's a cloud computing platform. It's a suite of services that you can use to develop, deploy and operate applications and other IT services. Has that now familiar model, which is you pay on the basis of consumption, and essentially you don't have to operate infrastructure. So you don't have to worry about deploying, scaling, managing failure conditions, or operating and maintaining the components that comprise the services that we provide. We do that. We expose them to you as a set of APIs, coupled with a set of SDKs that you can use to either control the services via a control plane or interact with these services via a data plane, okay? There's quite a lot of different stuff there. There's over 70 different services in total. Covers everything from simple primitives like virtual machines through to advanced abstractions like queuing services, remote code execution, database and analytical services, high volume stream processing services. We've got a suite of services that you can essentially plug into your overall application architecture and offload some of the heavy lifting associated with building these components to us. We'll build and operate them for you, and you can focus on the high value components that are unique to your app. Okay, so that's a 2-minute, 3-minute maybe, précis on what AWS is and the role it plays in the delivery of technology solutions for developers. Usage amongst mobile app developers is pretty high, and there's a good reason for that really. As soon as you put your application in an app store and open it up to global access, you're allowing your app to be used by an unconstrained number of customers, right? So if you have something that's very popular, it's pretty much impossible to deliver very popular mobile app backends without using the cloud. It just doesn't work, okay? Take Supercell on here, one of our top tier references definitely for usage in mobile app development. They've got Clash of the Clans, Clash Royale and Boom Beach. They're 3 of the most popular properties in the App Store, the 2 global app stores. And when they launched that title, they went from 0 to 55 million subscribers. Clash Royale went from 0 to 55 million subscribers in less than a day. Okay, so you can't build backends for products like that without the cloud. It's just not possible to do it. So we've got lots of usage amongst customers of this type. When you look at how AWS services are aligned to this use case, this Android development use case in this particular example, there's really 3 different categories that developers are interested in. They're interested in developing apps, they're interested in testing them, not just at the point at which they release them, but continuously testing them as part of a test-driven and continuous delivery cycle that they're engaging in. And then lastly, they're interested in measuring and driving up engagement of their users so that they can ultimately achieve their goals or monetize their app, depending on whether they're a non-profit or a profit-centered organization. And we have use cases in both halves of that camp. So AWS, essentially what we can do is, as I said before, generically really, but in the context of mobile app development, we can take away some of this heavy lifting and provide you with a set of services that you can consume so that you can focus on building the things that make your particular application or product or unique, and avoid focusing on things that everybody has to do. You know, the best analogy, and it's overused, but it's still good. Who generates their own electricity? You know, not many people. But if you go back 130 years, actually it was quite common for people to do that. Large industrial plants would have steam engines. They convert that steam power into electricity. Today, nobody does that. And we think that IT services and computing are going the same way. People aren't going to run their own. It's how you put the energy in that case to an application that matters, not how you churn out kilowatt hours. Make sense? So get away from that and focus on things that are more valuable. Let's take a look at development first of all. So there's a lot more diversity now in the targets that you're developing for. I'm sure you've heard in the last session a little bit about Fire TV and alternative screen formats, different devices that you might want to develop for. You've got usage in wearables, of course, and then you've got IoT and other connected devices. We could probably do, like we did at Linux London a little while ago, another hour on IoT use cases. It's not really what we're focusing on here. Here we're focusing predominantly on the top 2 use cases, which are traditional mobile experiences, maybe bleeding over into TV, and then wearable apps, okay? And you've got a lot of adoption across these different device categories. The other thing that's changing is the applications themselves are getting a lot more complex. You know, we've gone from that to this. Okay, and you've got lots and lots of different components that are in play in delivering a rich application experience for end users. Challenges like dealing with identity management, where users do not want to sign up for your app. They want to use pre-existing identities for that, right? And if you put a sign-up page at the front of an app, how many users do you lose that never actually get beyond that? Quite a significant number. So you want to have identities portable into the app. You want to have functionality that you can use for measurement, analytics. You want to have functionality that you can use to drive re-engagement through push notifications or SMS. So these are all natural characteristics of the sophisticated, but also the common pattern for mobile application development today. So how do we help? There's two important components, okay? The first thing is AWS Mobile Sdks. We've got SDKs for Android and of course for iOS. We're focusing on Android development here. So SDKs for Android that allow you to integrate AWS backend services directly with your app. This can lead you to a situation where you don't have to run a backend in the traditional sense. You might have deployed mobile backend infrastructure before. AWS Mobile Sdks. We've got SDKs for Android and of course for iOS. We're focusing on Android development here. So SDKs for Android that allow you to integrate AWS backend services directly with your app. This can lead you to a situation where you don't have to run a backend in the traditional sense. You might have deployed mobile backend infrastructure before. You might have run servers or virtual machines, and on those servers or virtual machines, you might have run APIs. You might have used Python Flask or a Ruby API management framework to do that, or PHP as an API backend. You don't need to do that anymore. You can combine these services together, and you can move towards this pattern that's emerging, which is called serverless infrastructure, where you have an API gateway wiring up your backend logic, but there's no fixed cost, there's no fixed computing resources. Each time you need to run an action within one of your APIs, we automatically create the execution environment for you. Your code executes, you get charged a few microcents, and then the environment gets torn down again. But there's nothing for you to deploy, maintain, manage failure conditions for, operate or maintain. We do all that as a natural component of the service. There are many other service elements here as well. Identity management with Cognito. What we can do here is map public identities that come from identity providers like Twitter or Facebook or Google into sets of credentials within AWS, and we can attach access policies to those AWS credentials that allow your users to perform operations using a principle of least privilege and also maintaining their publicly provided ID as a component of their credentials. So you, for example, could have large numbers of users coexisting, all of them storing and sharing their own media potentially, but each user that connected to your app would only be able to access their own assets. They'd only be able to access items that they had uploaded, because their identity would persist throughout the lifetime of those objects in this storage service that we provide. So that's Cognito with its identity management services. And then we've got other stuff as well, CloudFront for content delivery, SNS mobile push, which we'll talk about a little bit more. This is quite interesting. A non-relational database that runs in the cloud called DynamoDB, accessible directly via an API endpoint, so you have no server infrastructure to run. Very performant, consistently performant, even at very large scale. And it uses the same credentials model with Cognito providing credentials for access. So you can again have users be storing their state data for games or apps in DynamoDB, but each user is only able to access state data that they themselves have stored using their identity, all coexisting in one table. Very efficient and really not much to operate. And then we got some stuff on analytics, which we'll focus on a little bit more later, and also this AWS Device Farm testing service, which again we're going to come to in just a second. So, common feedback. There's quite a lot of stuff there, right? This is a common piece of feedback. AWS has too much stuff. Hear it quite a lot. Which option should I select? So, after this session, there's going to be another session with a colleague of mine called Paul Maddox. Paul's going to come in and show you a demo of a new AWS developer environment called AWS Mobile Hub. And that really simplifies the process of bootstrapping application development using these tools. It's an application skeleton generator, which will create a template app for you, including the services that you want to use for specific functionality, and it will spit out a skeleton within which you can start to write your own code. Okay, so we'll come to that a little bit later. Really simplifying the process of accessing all this stuff for mobile developers that just want to focus on developing their own app features. So come back for the demo straight after this session. So we're going to skip on through this stuff because this is Paul's content and he's going to talk about it a little bit later. So there'll be a demo of this and you'll be able to get an appreciation for how to use it. So that's development at the front end, choosing your services, minimizing the amount of heavy lifting that you have to do, and then using our quick start environment, AWS Mobile Hub, to build your skeleton app. What about testing? What is the primary issue with application testing for mobile developers on Android? Yeah, fragmentation. So I want to test my app on what? Okay, a lot of handsets out there, a lot of devices out there. And this is something that we heard back from a lot of customers actually. AWS, can you simplify the process of doing on-device testing for us? And to resolve this, well, to help customers resolve this, we created a service called Aws Device Farm. And this allows you to test using real devices in the cloud. Okay, so we, somewhere in the world, it's actually in the Pacific Northwest area, we have a large fleet of physical devices. Okay, and I mean large, I'll show you a slice of the list in a second. There's a lot of devices there. You, as a developer, can package up your app, you can remotely deploy it onto those physical devices. You can drive those physical devices using a GUI with a mouse, which will simulate taps and clicks. And you can capture log data, screenshots, and other data, which is an important part of your testing process. The whole thing is wrapped up in an API and can therefore be integrated into a test-driven development cycle. Okay? So it's physical devices in the cloud that you can use. And this is the process. You select the device that you want to use, you interact with it, and then you can view historical sessions and capture logging data. We have a lot of stuff. Okay? I couldn't get them on the screen. This is just part of the list. I think the list was about 5 to 6 times longer than this in terms of the devices that are supported. You notice we're only getting to A. There's a lot of Apple stuff. Amazon, Asus, we're at E here. And then there's a huge list of Samsung and other devices there as well. So you can access real physical devices for testing using the Device Farm service. Just pay for the amount of device time that you have. Okay? There's a generous bundling of device time in the free tier as well, so you can get started and experiment with it for a little while, work out whether or not this service might be valuable for you, and then you can put it into production as part of your test-driven development workflow. But they are real physical devices that you can run your real apps on and validate exactly how your applications behave on different physical devices. So that's very important for Android devs. Engagement. Okay, so if you can't measure it, you can't improve it. Don't know how much you know about, maybe it's been talked about earlier in the day, I wasn't here, I was at another event. Product and service development at Amazon. Okay, we do a lot of iterative development. In fact, everything we do is based on iterative development. When we launch services, we have 3 core tenets in mind: security, stability, and scalability. Okay, and we'll add features later on. So we'll often start with services that have a very minimal feature set. You might have noticed this about some recent service launches that we've had, where we've launched things and then we've iterated off that base. And the reason for that is it's very hard to retrofit security, scalability, or reliability into something once you've built it. Okay, you can add features till the cows come home, to use an English expression, but indefinitely. Okay, adding those core attributes to a service that you've already built is pretty much impossible, or at least very, very, very difficult. So part of that cycle is obviously feedback loops. So when we're putting things out there, we want to use data-driven decision-making essentially to determine whether or not customers think the feature or functionality that we've just shipped is valuable or not. We do a lot of assessment before we launch things, actually talking to customers and helping them prioritize our backlog and making sure that we're working on the next thing next. We do the right thing next. We do a lot of that. But once we get stuff out into production, we want to have instrumentation, right? We want to understand what the user journeys are through the apps that we're producing, what the features are that customers love and which features they don't use, so we can prioritize future investment in building on things that are popular. If it's gaming or other free-to-play apps where we want to monetize through purchase decisions, we might want to observe and learn about pathways that customers take that lead them to monetization events. This is done very extensively in the free-to-play segment, where they use lots of advanced techniques for observing the patterns of action or events that cause customers to monetize, that cause customers to be triggered to, or events that trigger customers to spend money on the game or on the app. And those patterns can be learned. Once those patterns are learned, they can be replayed. Okay, so you can see that 20% of the people in the room observe a certain sequence of events, and of that 20%, 3/4 monetize. So then we can play back that sequence of events to a larger population of people that are in the room, or a similar sequence of events. See if we can drive up monetization. Familiar concept to you guys? Yeah, okay. So how do we do that? Okay, how do we observe what's going on in our apps? Well, we need analytics to do that. And we've got a service for this called Amazon Mobile Analytics, essentially allowing you to capture application usage data at high scale, store that, and gain insights from that data. Okay? We provide a dashboard, actually, which gives commonly used metrics like number of sessions, daily active users, in-app revenue, lifetime value, predefined metrics. These all come with just one line of code from our SDK embedded within your application. You'll be able to see all this stuff, and we present it like this. This is our console. So you'll see data like that visible to you in the console if you include the SDK within your apps, this one line of code from the SDK in your apps. So it's very, very simple to capture. Talk a little bit more later on about other things that you might do with that data, how you might get further value from it. So we'll return to that in a second. But an important aspect of this is recall, re-engagement, encouraging customers to reuse apps that they might have installed, left dormant. Okay, you're certainly not going to get monetization opportunities if customers aren't using your app or aren't playing your game, all right? So the first thing that you need to do is get it on their screen and get it in front of their eyes, correct? Okay. So one of the services that we have that can help customers with that is the simple notification service. Now we can push messages directly to endpoints, notification endpoints that are provided by the FireOS environment, by the broader Android ecosystem, and via other mobile application providers as well, including several providers in China that support push notifications in the Chinese market, and Windows Phone. Okay, so we have broad support for different notification types. Here, you register endpoints, you send notifications to those endpoints, and for every million messages that you deliver, we'll charge you 50 cents. Okay, so it's high volume, mobile push, using non-SMS delivery methods, using API-based delivery methods that are present within the operating systems that we support. That's very, very common service, which is used by a lot of customers, used by Tinder, used by other customers at very high scale. Okay. And then more recently, we announced this. We did previously have SMS delivery for SNS messages, but it was in the North American market only. Okay. About 2 to 3 months ago, we announced global support for SMS delivery worldwide. You can now deliver SMS messages to mobile endpoints globally using the same service, using our SNS service, together with the global SMS feature that's there. Obviously, there's per country pricing. In fact, in a lot of cases, there's per operator pricing per country. So there is a bit of complexity here. It's hard for us to abstract that away from you. So we want to try and minimize costs, of course, right? So we feel it's better to have the lowest price for each operator rather than have like highest common denominator pricing where we may end up charging you more than you need to for delivery to some carriers. So that's an option that you have as well. Of course, you can also use AWS partners like Twilio to do this as well, but we have a native service for it as well today. So that's about re-engagement. What about decision making? So how might you use data that you gather from mobile analytics to help you take decisions? And there's basically 3 different models here. Retrospective, and actually that's, most of the history of analytics has been about seeing what's already happened, right? Yeah? So I want a regular monthly report that shows me my usage level. It's pretty common. Then we've got ad hoc. So I want to equip some analysts or data scientists with the capability to interrogate a model or interrogate a data set and build their own hypotheses and then draw conclusions about those hypotheses using a data set that's available to them. So that's the second option. And then thirdly, becoming increasingly common is predictive. One of the best and most well-known examples of this is clustering. I've got populations within my customer or user base that have things in common. I don't care what the things are that they have in common. I just take a decision that I want to segment my user base into, say, 5 different segments. Then my analytical model can be created which will group my users into 5 populations that have commonality. At this stage, you don't know what the commonality is. Then you come along and look at the populations. You can work out by evaluating those populations what those users have in common, and you can use those clusters as a mechanism for improving efficiency. It's very often used in things like targeted marketing activity. You know, I've got this population of users over here. They monetized on this particular game once. They've never monetized again, but that's the primary thing that they have in common. Oh, by the way, they're all or majority of them are in the 18 to 25 age bracket, and they live mostly in Western Europe. So maybe I could use that information to run a campaign, maybe a media campaign, targeting my user base in that particular geography, in that particular demographic segment, to try and get them to re-engage with the product. But because I know the characteristics of the group, by looking at it, I can target my spend. You know, I could target my media campaign on media that addresses that demographic in that particular geography, and be more effective as a result of that. That's how we tend to use that clustering. That's one example of predictive analytics. So how can we help support these different options? So in the context of the mobile app, we can use our analytics loop to gather information about usage. Okay, we can maybe use that information to enable us to draw insights about usage, about behaviors, maybe even predict user behavior and use those predictions to enhance their experience or to enhance our business outcomes. So when we're talking about monetization, that'd be the predictive model that I described before. Okay, and then we can take advantage of some AWS services to help us get away from this retrospective model into enabling our teams to drive some of this inquisitive behavior, to start to ask a few questions, test a few hypotheses, and either prove or disprove those hypotheses with data. And one of the ways we can do this is by enriching data that we get from our mobile analytics SDK, our service endpoints. Okay, so I talked about adding 9 simple metrics with 1 line of code. Well, you can add more, you can extend that. Once you've extended that, you can then automatically get that data out of our mobile analytics service into some of our more general purpose analytics tools. Okay, Amazon S3, this is the object store that I talked about before in the context of storing assets for mobile apps, but we can also use it as a data lake, as a data repository for information that we want to load into, say, a data warehouse or a Spark or Hadoop cluster for processing. So it's a large general purpose storage service that actually has quite a lot of different applications. Once we've got our data in there, we can then start to apply computational resources to it in these other services. One example would be Amazon Redshift. This is a fast petabyte scale data warehouse that you can create in the AWS cloud in just a few minutes. You can load data into it from S3, and then you can analyze that data using standard SQL-based query tools. Okay, so it presents an ODBC or JDBC endpoint that you can plug Tableau or Jaspersoft or Excel for that matter. Anything that supports the ODBC, JDBC driver standard can communicate with Redshift, can issue queries to the data set, and can get results back. Okay, so your analysts can use that to build analytical workflows using the tools that they're already familiar with. Then we've got this capability to extend. So this is standard fields that are going to be captured within our mobile analytics environment. And then we can enrich with custom fields that we generate, custom data points that we generate when certain events are triggered within our app. Okay. We can really put whatever we want in here, monetization events, trigger events, maybe somebody reaching a certain level or acquiring a certain piece of equipment inside a mobile game. All of this can feature in our model. We can capture that data, and then we can use that for these analytical workflows. As I said a second ago, you've got access to all these industry standard tools. Amazon Redshift, which is going to be our query engine in this case. We're dealing predominantly with structured data here, so we're using Redshift as our query engine. And notice that you can integrate data from other sources as well. These could be external tables on Redshift, but more likely you'd actually ingest this data into Redshift as well, and that would enable you to join data sources, analytics from the mobile app, plus other insights that you might have about your customers, demographic data, usage data, lifetime value data, and consolidate all those things together to allow your analysts to take a view over all of that different data using any one of these tools, plus any other ODBC or JDBC compliant tool. This warehouse, by the way, like all AWS services, you only pay for the period that it's running. Okay? So it's by the hour consumption. And in doing that, you're not forced to bear the costs of running a data warehouse all the time. Maybe you only want to perform this analytical activity once a month or once a quarter or for 2 weeks after you've shipped a new release. And it's fine to do that. You can store your data in S3, very low cost, very durable. And when you want to process it or gain some insight from it, you can create this cluster on demand, use it for the period that you want to use it, and then just discard it at the end and re-establish it the next time you need it. It's one of the main differences between using the cloud and using traditional IT resources. You're only paying for the period of consumption. If you do want to make this a permanent feature of your infrastructure, you can actually forward reserve this service. And if you do that, you'll take the cost down to about $1,000 per terabyte per year. Actually, very, very cost-effective way to access a high-end analytical database if you do that. Okay, so we'll talk very, very quickly about predictive analytics. We've not got a lot of time left, okay? So what are we talking about here? Well, we're talking about predicting user behavior in the main part, either for personalization. It's very common in retail. It's very common in online video apps as well. You know, you watch this, and because you watch this, we think you might also be interested in these 5 other videos or these 5 other pieces of content. You see it happens all the time with Netflix, Amazon Prime Instant Video, even YouTube uses the same thing. So that is recommendations. What we might be more interested in is we've seen other users go through this pattern of activity and it's caused them to monetize. So let's try and replay that to you. And for this, we've got another service. It's called Amazon Machine Learning. It's a predictive engine that allows you to build prediction models. And really what it works by making probability assessments about what the most likely answer is. So you'll have a data set that you train the ML service with. Then you can start to submit new data items that might miss one or more of the fields that are present in your training data set. And our ML service will make a probability assessment and suggest the most likely correct piece of missing data. So essentially filling in the blanks on a set of data that you want to make predictions about. And this can be used to drive many different use cases actually for analytics. A few examples that we've seen used commonly in the mobile environment: prediction of users with high probability to churn, and then using that for re-engagement notifications. That can be an entirely automated process. We're seeing a pattern of usage which leads customers to stop using the app. We want to respond to that. Okay? You can predict users that might have a much lower than normal probability to monetize, and you can use discounting via in-app notifications or SMS push to encourage those customers to spend. Okay? So trying to convert customers that might never monetize into customers that will have 1 or 2 monetization events at a lower value, and then hopefully you can convert from there into more regularly monetizing customers. Identifying users that have a high probability to be viral sources, okay, high probability to be kind of super networkers in a community of users and encourage usage. That's quite an interesting use case. And then lastly, the familiar content recommendation use case, where we've got customers that exhibit certain purchase patterns, buy certain virtual items perhaps, or certain real content items, certain real physical items, and we believe there's an adjacency there where we can tip them over a tipping point and encourage them to buy the next most likely item on their list. Okay, we use that a lot at Amazon, as you'll know, with our retail recommendation engine, which I now forever recommends that I buy baking equipment. Not because I bought it for myself, but because I bought my wife some cutters for cutting out sugar flowers, and now I love baking. Okay. I do love baking, but I love the eating part of it, not the making part of it. Okay, and with that, I think I'm going to close up and say go here to awsamazon.com/mobile if you want to learn more. Might have a minute, have I? Got 1 minute for a question. So does anybody have a question? I'll answer 1 or 2 questions. Yes? We don't actually... yeah, so it's... So we haven't actually said publicly what algorithm we're using. We've said that we have a probability model for predicting missing data in sets, and we build a probability model, and then we'll predict missing data in sets. We do have something else for ML actually, which we just announced this week. So this week we announced something called the P2 instance family, which is a super large category of virtual machine that has GPUs in it. They have, I think the big ones have 30,000 floating point unit cores in each machine, okay? And with that, we announced an Amazon Machine Image, which includes in it a variety of machine learning, deep learning, open source packages, okay? So if you want to have more flexibility about the algorithms that you use, maybe run a neural net or deep learning package like TensorFlow or our own Destiny deep learning package, you can run that on these machines, and on that you can use the primitives and have full control over the algorithms that you use to build your models. With our service, we haven't actually disclosed what the algorithm is. We rarely do that. We normally focus on the API for interaction and the outcomes that you're going to get from our services, and we rarely actually disclose what the implementation internals are. So if you want more control, you've got a different option. Okay? Question? Oh, that was the same question. Okay, so check out that blog post on the P2 actually if you're interested in that. It's pretty interesting. And as I said, we've got this packaged army which includes all of these different open source deep learning tools all in one easy to access bundle. So it's well worth taking a look at. Pretty good, pretty interesting launch last week. Anything else? Any other questions? Okay, I'll thank you for coming to my session. Thank you.